So this is the fifth part of our series of presentations on two-sample inferences. In this part we are going to look at hypothesis testing for the difference of two population means. So this is the population proportions. So this is the population proportion for population 1. This is the population proportion for population 2. Just as a quick remark, I usually write it as pi 1 and pi 2, and in some books that's how they would be written, but actually it's just easier to type P1 and P2 in this case, so that's why I've gone with P1 and P2. So we're interested in the difference between these two population proportions. Now, in general, there are three types of hypothesis tests. This is just a little bit of revision. There is two one-tailed types of tests. Both of these. And there's also a two-tailed test. And indicated by what's characteristic of the two-tailed test is the not equal to sign in the alternative hypothesis. So the difference in populations, look at this one here. Difference in population proportions, P1 minus P2, is that greater than or equal to 0? Or alternatively, is it less than 0? P1 minus P2. Likewise for the rest of them, there is P1 minus P2. P1 minus P2 is that equal to 0? P1 minus P2 is that not equal to 0? Just a little bit of clarify a few things. In general, this is what we're interested in. This let's do this in red. P1 equal to P2, or P1 greater than or equal to P2. But in general, P1 equal to P2. Another way we can express this is P1 minus P2 is equal to 0. That's why we have them in the form we do, P1 minus P2. So if it is equal to 0, it's not equal to 0. Is P1 greater than P2? Another way we could write that, P1 minus P2, is that greater than 0? So that would explain the way these null hypotheses and alternative hypotheses are written. So those are the three types there anyway. Just one more remark. Yeah, no, I think I pretty much covered everything. I'll move on from that. So now, when you are carrying out hypothesis tests with the on the two population proportions, one thing you need to know is the standard error, how to compute the standard error. Now in this case it is quite a bit of work. So the first part of it is, this is the standard error here, the standard error formula. Okay. Now it is the square root of p bar times 1 minus p bar by 1 over the sample sizes. So 1 over the sample size, add them together, and you get a number there. This is particularly important, the pooled estimate. So this is an aggregate proportion, essentially. Aggregate proportion, disregarding which group it is in. Another way you can write that actually, or n1 times p hat 1 is actually simply the number of successes for population 1 plus the number of successes for population 2 all over the total sample size. Okay, now that's just a reworking of the formula. That's just x1 is number of successes. Number of occurrences, actually, probably a better word. Okay. Anyway, so that's an important step there. You might sort of see this when you're working with your formula sheet. You might actually see these two expressions together. So it's actually a big long calculation broken up into two parts. Okay. Now, test statistic. In general, the format for a null test statistic is the point estimate, which is P1 minus P2, Now, usually you'd have minus the expected value under the null hypothesis, but nearly all, in pretty much every case when we're dealing with P1 minus P2, it is 0. So it's the null hypothesis value. And that's just equal to 0. On almost all population proportions questions, it's equal to 0. So P1 minus P2, this part here is the standard error. Again. Okay, so point estimate, expected value under null hypothesis, or null hypothesis value, divided by the standard error. So that's the general form of a test statistic. So, this is from an earlier example I used in the previous part. So this was related to an advertising campaign before and after the awareness of a product before and after an advertising campaign. Before, it was 60 out of 150 houses. Okay, and P1, or this is actually P2 actually. So P2, the estimate for P2, and that is the number of successes divided by the sample size. In P1, after the exercise, which was called P1 bar, we had 120 out of 250. That is the number of successes out of the sample size. And again, that is after. Okay. So if you just want to quickly revisit the previous presentation in case you haven't seen it. Another thing to remark upon is the 5% significance level. Okay. Alpha equals 0.5. 0.05 even. So develop the null hypothesis. In this case, we're interested in, was there an increase? Okay. Again, after did the advertising campaign increase awareness? So was there a positive difference? And we would sort of express that in the context of the alternative hypothesis. We're interested in, did this advertising campaign work? Did the proportion of people who knew about the product increase before over the course of the campaign? Is the probability is the proportion for after greater than the proportion than for before? That's what we're interested in, and that is encapsulated in this alternative hypothesis. Now, the null hypothesis is the opposite of the alternative hypothesis, and so it means that there was no difference, or no difference, or possibly even a negative difference. Bit unlikely to be a negative difference, but anyway, P1, proportion of population of households aware of the product after the campaign. P2, proportion of population of households aware of the product before the campaign. So just clarify which is which. So level of significance, alpha equals 5%. Now, this is where we are going to carry out the we're going to compute the test statistic. Now, I have it done here, but I'll actually do a much simpler format here. Overall, the pooled proportion is as follows. So it was 60 plus no, actually start from the other side. It was 120 plus 60 over 250 plus 150. That works out to be 180 over 400, and that is where we get this value here, 0.45. Okay. Now, the 1 minus 0.45 is 0.55. That's where we would use, so that's where these two values come from. The pooled estimate and the complement of the pooled estimate. Now the sample sizes are 250 and 150, so we evaluate them like that, 1 over 250 plus 1 over 150. Now working all of this expression out here, working all of this out together, we get an answer of 0.0514. Okay. Now, so our point estimate was 0.8. 0.08, and our standard error, our null value is 0, which is just disregard that. Our standard error is 0.0514. Therefore, our test statistic is 1.56. Okay. So that's our test statistic. Now, it's gone missing here. Hang on a second. Let's go back here a second. Now, I messed it up there. Hang on a sec. There we go. Now, determine the critical value and rejection rule. So we have an alpha of 0.05. Now, just as a remark, what we're dealing with is a one-tailed test. So this is a one-tailed test, if you recall from earlier on. And the significance level is 0.05. So the quantile, the critical value, which you'd find in statistical tables, is 1.645. And our rejection rule is this: reject the null hypothesis if the test statistic is, that's the test statistic there, if it's greater than the critical value. So test statistic greater than critical value, or greater than or equal to critical value. In this case, it's not. We have 1.56 is our test statistic, 1.645. So in this case, we fail to reject the null hypothesis. Fail to reject. So we cannot conclude that the proportion of households aware of the client's product increased after the campaign. So essentially, it looks to us that the campaign was not effective. Anyway, that ends our presentation.